This is Lab 4, the oscillation of a spring mass system. My name is Chuck Eisenhower, Physics 2211. So first off, the purpose of this lab was to simulate the physics of extreme sports with ropes by observing the motion of an oscillating spring mass system. So swinging in an arc while oscillating on the spring. How we're going to do that, we're going to use V idle to predict the motion and compare it to the observed motion. And the results were that the predicted motion lined up really well with the observed motion with minimal error. The two lined up very well, and it satisfied the energy principle. So here's the initial video. You can see that the calibration stick was used as a calibration measured of 0.7 meters, and that the origin was placed at the fixed point of the spring. Up in the top right corner, the two graphs are the position data, and the XY data from the table was exported to a CSV file that I would later use in my code. We were given that the mass was 0.402 kilograms. The initial velocity is starting from rest, so it's 0 meters per second, and the initial x coordinates and y coordinates are negative 0.114 and negative 0.637 respectively. So there's going to be three principles that we're mainly using here. The first one is Newton's second law, second one is the momentum principle, and the third one is going to be the energy principle. So first off, we need to find the period. The period is going to come from that graph back from tracker, and it's going to be the time it took for 3 oscillations divided by the number of oscillations, which I found to be 1.52 seconds. And then once we have the period, we can use it to find the spring constant K, which is up there in the upper left, and K was found to be 6.87 Newton meters. This is about the same as what was used in the lecture videos, which was 6.83, but mine was a little different. We also are going to find the relaxed length of the spring using the spring constant and using the knowledge that the force of the spring is going to be equal to the force of gravity. And so the relaxed length was found to be 0.12655 meters. So the results are that, as you can see, the position data in the upper left, the y position lines up well with the predicted motion. The actual predicted motion in the model is up in the upper right, and the graph below is the graph of the energies, where the red line is the change in potential energy of the spring, the blue line is the change in kinetic energy, the green is the potential energy due to gravity, and the yellow is the total energy on the system, which is a constant 0 throughout the entire thing. So now on to the questions. Is the energy principle satisfied? Yes, because everything is included the system. The change in energy of the system is going to be equal to the work done on the system, and because you're including everything in the system, there's no external work being done on the system. As you can see from the graph, it was 0 the entire time, as it should be. And the second question was asking about whether you used X or Y, if that made a difference in the period of oscillation. When I used Y to find the period, it was about 0.2 seconds less on average than the X values. This could possibly be due to the gravitational force that's going to affect the Y values, and over time its change. So yeah, thanks.